Okay, class, picking up where we left off at, we were at C, which is B intersects C. So what we would do is this here, we would look at region B, well, set B and set C, and we would look where they intersect at. B and C actually intersects here. B intersects C intersects here and also here. So it'll be 5, 7, 9. Now we have C prime. So now we look at all the values that are not contained in C. We look at all the values not contained in C. We will have 11, 3, 12, 1, 2, 10. So it'll be 11, 3, 12, 1, 2, and also 10. That is our C complement. Now we have A intersect B intersect C. All this is saying is the values that are in A, B, and C. And that only falls here, which is 5 and 7. Okay, now if we scroll down here, if you notice, we have the answers to the solution set here, the same answers that we just went over. But there is one other thing. For some reason, this drawing does not have the number 4. So what we need to do here is you need to scratch out 4 because we don't know where 4 is at in this diagram up here. So you can scratch out 4 and this will be the exact answers that we had. Now we go here to example. We got the universal set, which here is 1 through 15. And we have A, B, set A, B, and C. It says find the following sets. Now we could do this one of two ways. We could write out the Venn diagrams for all of these values, or we could basically solve this by looking at the values that we have presented in front of us. Like for instance, if we look at B intersects C, we could just look at B and C and see what they have in common. What they have in common here is just 12 and 15. So B intersects C is 12 and 15. Now we have A intersect B and C. So now what we need to do is list the values of A. Now the values of A we know are 2, 4, 6, 8, 10, 12, and also 14. Now we take the values that match up here, which is only 12. So A intersect B intersect C is equal to the set of 12, which we have here. Now we have A union B intersect A union C. So A union B is all the values of A and B that do not overlap. Because the ones that overlap, we would just count them once. So let's just write them out. So we had A, which we know is 2, 4, 6, 8, 10, 12, 14. And we also have B, which is 3, 6, 9, 12, 15. Now when we union A and B, that would give us 2, 3, 4, 6, 8, 9, 10, 12, 14, 15. So A union B is a set of 2, 3, 4, 6, 8, 9, 10, 12, 14, and 15. That's A union B. Now we look here at A union C. Now we can write C over here. C is the values of 1, 5, 10, 12, and also 15. Okay, now if we look here, we take A union C, we will have the values 1, 2, 4, 5, 6, 8, 10, 12, 14, and also 15. Now what we want to do is intersect these two values. Now we look at the values that are alike. We have 2, we have 4, we have 6, we have 8, 10, 12, 14, and 15. These are the like values. So as we see here, A union B intersect A union C is 2, 4, 6, 8, 10, 12, 14, 15. So that will be your final answer. Now we can write this out. Have A union B, parenthesis, intersect A union C, which would give us 2, 4, 6, 8, 10, 12, 14, 15, which is the exact same answer we have here. Now we scroll down. We have example, let the universal set be 1 through 10 using Roman numerals, and we add the values for A, B, and C. Now we have A intersect C intersect B prime. So basically, we want these to intersect basically what's in A and C. Because remember, well actually, A, C, and the universal set. So let's do A intersect C. A intersect C. We look here, we have only 9 and 10 in common. Yes, 9 and 10. And then we want to intersect this with B complement. B complement is all the values is not B. So that's 1, 2, 3, 4, and 5. So then that will leave us 6, 7, 8, 9, and also 10. Now the only things that intersect here are 9 and 10. So A intersect C intersect B complement is equal to 9 and 10. And that is the final answer. Okay, class, we'll start on example 2 using the same set of directions as example 1. Now we have A intersect B intersect A intersect C. Okay, so now we look at A and B here. Now we want the intersection of A intersect B. Now the intersection of A and B is 1, we have 3, and 5. 1, 3, and 5 are the intersections of A and B. Now we need the intersection of A and C. The intersection of A and C is 9 and 10. Now, what we want to do here, our next move would be that we want to intersect A intersect B and A intersect C. So, we will have A intersect B intersect A intersect C. Now, if you notice, we have nothing in here that matches up. So our answer is the empty set. Now we go here. We have A prime or A complement union B complement intersect A union C. So now first, let's take a look here. If we take the complement of A and also the complement of B, the complement of A is basically all the values that are not contained in A, which would be, we have 2, let's see, we have 4, we have 6, we have 8, that is it. That's not contained in A. Now we need to go to B. Now B is all the values that's not contained in B. We have, it'll be 6, 7, 8, 9, and also 10. Now, if we look here, well, let's go here with the union of these. We will have 2, 4, 6, 7, 8, 9, 10. So A complement union B complement would give us 2, 4, 6, 7, 8, 9, and also 10. Now what we have to concentrate on now is A union C. Now what we could do with that is this here. But first let me write A union C. So we can go and take a look at the values for A and C. For A and C, it looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, A and C has all of the elements. So we will have 1, 2, 3, 4, 5, 6, 7, 8, 9, and also 10. Now, we want to intersect these values. So we will have A complement union B complement intersect A union C. Now if we look here, all the values that match up, we will have 2, we will have 4, we will have 6, 7, 8, 9, and also 10. And this is our final answers.